Okay. All right. Thank you. We're talking about disaster recovery and backup and recording. Okay. Backup and recording and restoring. My brain is fumbled right now. Because basically, let's talk about this for reality here. When I was at Foster Farms, we actually had a full-on data, that's what their job was, data disaster recovery. And that was part of their job description. And they were a project manager type person. So they weren't super technical, but they knew how to get stuff done. And basically, the company that they decided to use is this one. And I'm going to go ahead and bring it up on a browser so you can see it. Oh, that didn't work. Hold on a second. Okay. This one. There we go. I'll do this much of it. Here we go. All right. Now I'm going to go back over to screen share now. I'm going to talk about this particular company. I'll just do the whole screen, not just the window. Okay. This is the company that Foster's paid money to, SunGard. And this is their specialty. They actually specialize in keeping companies like Gallo and Foster Farms up and running. I want you to think about the top line of Gallo. They're a multi-billion-dollar company, multiple billion dollars. And I know Foster's is around 2 billion. Imagine how much it would cost the company to have 1 hour of downtime. That means the trucks aren't moving, chicken are not getting processed, they're not being taken out of the houses, grain isn't being delivered, trains aren't moving back and forth to move up and down to move into the granaries. Feed formulation is not happening. That's a lot of people doing a lot of jobs, costing a lot of money. Because one of the things that brought this to a head was, at least for Foster's anyway, in Livingston, this was mid to late 90s, and we were having trouble with rain. And come to find out, there is a 500-year floodplain right around Livingston. And the disaster that we were actually mitigating for was, what happens if our main plant and computer room flood? You know, that means business stops. Here's another very scary statistic. Of a large company, large, I'm talking, billion plus. This is something that SunGard will tell you, that if you're down longer than 3 days, you may never recover your bottom line. Imagine Ford or Chrysler, Boeing, down, literally, couldn't do a thing for 3 days. This is pretty high stakes. And the problem with this is most people just assume everything works because that's the way it's always been until it doesn't. And that's where the system administrator gets, finds out that everybody in the company knows his name. And you do not want to be there if you are a system administrator. If you're doing your job, nobody knows your name. They only know your name if something's broken. So 3 days, that's a pretty serious number. You can lose market share and never recover. Okay. Now this company, SunGard, basically the way they had provisioned it, and it was quite expensive. I don't even remember what the cost was, but it was a lot of money. And basically they guaranteed that if we had our nightly backups that were rotated off site, so you back up your stuff at night, you take it off site, and then the next morning you bring them in, and then that night you take another copy off site. So you have this rotating off site backup. Sometimes it goes with people, sometimes you have multiple off site backups. And SunGard basically promised, we will have your computer room up and running within 24 hours of this disaster for flooding. And if we don't hit that number, you get to charge us. Talk about high stakes. That's a lot. You take $1 billion a year and you start dividing that out by 360 days a year for how much money per day Foster makes. That's, weekday, mind you. That's a lot. Yeah, no pressure for sure. Now, this is serious. And one of the things that Foster's invested a lot of money in was called the Tivoli Storage Manager by IBM. And what this storage manager did is it worked in conjunction with the SunGard, because this is the backup facilities that they used. And if you scroll through the SunGard site, they have data centers all over the country, all over the world. And they have some standards. And if you adhere to their standards, you can send them tapes and they can actually spin up things for you in their computer room remotely. So if you can send your people to higher ground, so to speak, say, let's go to Mariposa, we're going to go work from a hotel for 3 days, and you can still get your job done. Okay. So interesting things, but this Tivoli Storage Manager, the claim to fame is the speed of restore, not the speed of backup. And we ran this through the paces. What we did is, we did the backups like everything else, and we had individual backups on individual PCs throughout the enterprise, the mission critical PCs. Not everybody's PC was considered mission critical. And then we randomly picked some file to retrieve from the huge backup. And it was amazing. It was completely amazing. What we ended up doing is one of the QA people said, let's recall an email from the boss's inbox from 2 days ago that was sent to me. And believe it or not, the Tivoli Storage Manager got that file back out of, I don't know how much data, terabytes of data, in less than a minute. It was crazy, unbelievable how fast that restore was. And that's why it costs over $1 million. Okay, it's a very expensive system, but the speed of restore can save so much money. Because let me tell you, when it comes to backups and security, there's never enough money until you have to rebuild a system from scratch off CD. And then guess what? There's all kinds of money for backup after that failure. Okay, it happens all the time. There's no money for a firewall. Well, you get hacked. Well, there's all kinds of money for a firewall. It's always after the fact. Yes, speed of restoration is key for large companies. Okay, when you're a small company, it's not, you don't care if it takes 1 hour or 5 hours to restore. Okay, but these big companies that are doing billions of dollars or millions of dollars in transactions an hour, like Visa, yeah, that's a really big deal. Now, I want you to think about something while I still have this screen share going. You can see that all over the place. You can find one that's closest to you, and you can do tours. And if you go back to just sunguard.com, they give you an overview of what they do. This is their forte. This is what they do. They actually come in and do security, resilience. This is what the DR is all about. And actually, how do you best buy the big stuff that you need to run your enterprise? Now, here's a question for you. I love asking this question. Let me go back to here. Here we go. This one right here. Would you use your credit card if it took 5 minutes to validate? You know, every time you use a credit card, you'd have to sit there and wait for 5 minutes. How many people would use your credit card? Yeah, exactly. You know who the biggest purchaser of mainframes are? The credit card companies. Because mainframes are king when it comes to I/O, input output. You cannot go any faster than a mainframe when it comes to massive I/O. Think about Christmas time and how many people are using their credit cards, and how long does the average person have to wait at Christmas to get their credit card validated? It's less than a couple of seconds. Now think about that on a global scale. That's really serious computer science going on, okay? So, and yes, Visa, American Express, MasterCard, all these Discover, big credit card companies have multiple redundant computer rooms throughout the world. And what they look for is cheap power and geologically stable. In other words, they don't want it to be on earthquakes, duh. And they want it to be, you want to put these big computer rooms next to cheap power because they're expensive to run, okay? All right, so we're talking about a little bit about just how this works. Now, the other question here is that I got this story from a student of mine who started out life on the, shall we say, the gray black hat side of things. He got into security. He was on the red team for a lot of companies. And he says, you know what, after a while, it gets boring. It's more fun to be blue team. And he was telling me some of the stuff he did in his early days. And what he did is there is a, what they call let's see, the drive, golden. Okay. Most companies have this concept, all right? It's a golden drive. And what this means is this is the drive that you use to build out your computers. So it's got standardized software, standardized things, users change their password when they log in, this golden drive. Well, what he did is, in his bad days, is he found this company's golden drive and infected it. So every time they restored from their golden drive, they got the virus again. So this is why practicing restore, even from a golden drive, is something you need to verify. Just because you restore it and it works, well, you need to do this on a quarterly basis to make sure it hasn't been infected or obsolesced, because you don't want to restore something. Let's say you've got a Windows golden drive here, and this Windows golden drive has not been updated for the past 18 months. And there happens to be this huge security flaw that's not patched on the golden drive. So when you restore a machine, you've just opened up a major security hole. Okay. So all this is part of disaster recovery when you have to rebuild everything from scratch. And I do have a true story here about this happened during my days at Foster's. And it was really interesting. It was a cacophony of errors. And what I'll do is I'll stop the share so you can kind of watch me do some scribbles on the board. And we zoom out a little bit. So we have the golden drive. I'll go about to there, I guess. Okay. The golden drive. So you want to make sure that it stays golden, and you want to make sure it's patched and so on. Because I know companies that have a golden drive and they don't touch it ever. Oh, we will add all the patches after we get the machine installed. No, you want the patches before the machine is connected to the network. I had a brand new server that I was going to put into the computer room on West Campus. I used a weak password, and within a day it had been hacked. I was rather amazed because the password wasn't that weak, but it was weak enough. And I go, whoa, that's pretty cool. So what we did is we brought it back over to here, and then I turned the students loose on it to figure out the virus on it. And it was pretty amazing what they managed to get. It was all, you could tell it was all scripted. These bots come out there and they look for something, and they look for an open port, and they just start brute forcing the username password pair. And boom, they got in. It's pretty impressive. Okay. But what happened at Foster Farm, it wasn't necessarily under my watch, but it happened during my watch. So I was kind of involved. But let's talk a little bit about this disaster recovery piece part and security. Okay. Most of you deal with software on your PC and then the hardware that is made up of your PC. Now, let me ask a question. How many have updated the firmware on your BIOS or controller card? I'm curious to find out. I see chats flying by here. 1, 2, 3, 4, 5, 6. Had to. This is good. You're understanding this. I'm scared to mess with my BIOS. Yeah, that's a good thing because it can really screw up your system. But in the world of IBM and AIX, firmware is a very big deal. You don't have just a hardware software division. You've got your software over here, major firmware, and then your hardware over here. Okay. I may have talked about this in the past, but what had happened was the firmware had never been touched on this particular unit. And it happened to be on the payroll lock. Well, the software had been updated, and it was running at the time the latest version of AIX. So I'll just call it AIX. I don't know. I don't remember what it was, 4.1 or something or other. I think they're up to version 7 or something. Okay. But it was working. Okay. And we had some problems with the hardware. And the IBM tech told us, oh, go through and do this, 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 and this. So we did. And the machine would not boot. We could not get the machine to boot, no matter what we did. And we had to call tier 3 engineering support. And they said, this machine was never supposed to run AIX 4.1. How did you get it to boot? And we are all going, I don't know. And they said, oh, they went back and they looked through all the records, and they found that we had a beta copy of the firmware that was never publicly released. So when we were doing security updates per Y2K, we couldn't get the payroll box to boot. And of course, it was our fault, right? It had nothing to do with IBM, nothing to do with bad communication. And the person who originally set the machine up was gone, nowhere to be found, okay? And basically what they did is they got it running and never touched it. They never added patches. They never did anything. They just got it running and never touched it. And their approach was, it's sacred, don't touch it. You just bow and worship it. It's the payroll box. And I go, yeah, right. Okay. But we were modernizing because we had to. Y2K was coming around the corner. And this is the kind of thing that got management's attention, that said, hey, you know, we do need money for Y2K. Look what just happened. Well, needless to say, that was on a payroll run day, and it was a very long night for a lot of us. So what we ended up having to do was build out the firmware with all the latest patches, update the software with all the latest patches, and actually reinstall from scratch the payroll system with the COBOL compiler and the Oracle database and all the custom code from the previous night's backup. Got it all working. We didn't miss any payroll. But the next time that payroll system came up for renew, Foster Farms remembered that pain point and they outsourced it to the company that actually did payroll. Okay. Here's something else you need to consider when you're in business. Is payroll your primary business function? Yes or no? If it's no, then you can get some optimizations by outsourcing it. You can reduce headcount, machine count, time count, downtime, and it's all part of the contract and the service level agreement that you negotiate with a vendor. You know, so cloud provisioning is nothing new. It's just the way it's been packaged lately is they make it a little more palatable to move more and more stuff out there. Okay. Now, this is a true story. And what do you walk away from this? You got to have good backups, and you've got to stay on top of the security, because if you let it get too far behind and you make a leapfrog, you may not get that machine to boot. Okay. Because the security patches that we were rolling in were actually at the firmware level. So we had to do it, okay? How come we don't get firmware update messages like we do with software or BIOS update messages? That has everything to do with the hardware you're running on. Like I have a rather crappy notebook, but based on the software I chose to use, it tells me when my firmware will go out of date. Okay. It's an option that you can check. You can also go into the BIOS settings and look at the manufacturer's BIOS, and then go to their website and find out if there's an update to your BIOS on your computer. Okay. And you got to blow up your BIOS once or twice in your career. Come on. This is how you learn, right? So you get to restore from your previous backup. It's so much fun. Yeah. Okay. Actually had to rebuild my crappy notebook because I had a failure in the latest kernel. The latest kernel, 5.15, will not compile the VMware Workstation editions, but 5.13 would. So I had to roll back my kernel and recompile, and it works. But in the process, I was doing a bunch of other things, and I pretty much hosed my system. But I have backups, but I do backups in a slightly different way. I do something called what they call cold backup. you put in another drive and you boot from that other drive, like a Kali Linux. And then you make an image of your entire hard drive, everything, all the crap and everything, and put it on another disk. Then you put that disk as part of a virtual machine and you boot it. So you can actually boot your old machine as a virtual machine on your new machine, which is really kind of cool. You know, it saves a lot of headaches. Okay, because then you're just running it. That's basically a stripped down version of the cloud that I'm playing with. Is because what I'm doing is that I'm taking a copy of my working machine, virtualizing it, and then I am booting the virtual machine so I can make sure I've got everything in when I have to restore it. Inception stuff, yeah, maybe. But this is not a new idea. This was around in the 80s on the mainframe, and they called it pseudo volume. You take an image of something, and then you boot the image, and then you have another LPAR on the mainframe of a duplicate of what you've got, so you can do the equivalent of snapshot on the mainframe. So where do you think VMware got this idea from? Okay, these are not new ideas. Okay, all right. So this sort of thing with disaster recovery is how fast can you recover when your machine gets hosed? One way to try it is if you got a machine with a boot drive, yank the boot drive out, put in a new boot drive, and see how long it takes you to bring your machine back. Just as a practice. It's actually really good practice because you have to get comfortable with backing up, initializing, and restoring your machine, because when you're under pressure, that's not the time to learn it. Okay, that is not the time to learn it. Okay. All right. Now, what I want to do now is show you another picture, and I'll bring it over into the screen share area and do screen share again. Share. You should see a graph. And what we're doing here is we're looking at risk and a project. Now, what I'm going to do is give you some biases that I have based on my years of experience. These are not golden rules, by the way. These are just my opinion, and it's worth what you pay for it. You know, since the semester was free, your books were free, so maybe you paid $7 for the Brian Larson book. Okay. But basically, it didn't cost me anything. So this advice doesn't really cost you anything either, okay? When you're running a project, there are certain kinds of projects that bring more risk to the day-to-day operation of your company. Others, not so much, okay? So I showed you this curve. It's kind of a messed up hysteresis curve. So I'm going to stop share for a second. I'm going to draw on the board. And the projects that, there's a bunch of them, but I'm just going to highlight a few. One of them is called direct cutover. And you can imagine what that is. And then there's something called parallel. Okay. There's phased. And then there's the pilot. Okay. These are different ways of running projects, okay? Now, running a direct cutover project is exactly what it sounds. You have old, date, new. You can see that that is an extremely high-risk proposition, because if your direct cutover doesn't cut over, you're toast. So one of the things that you want to put in big magic letters in your notes, do not bring over history. If you're doing a direct cutover, do a direct cutover. Open records, maybe, but don't bring over your 10 years of online history. It's just going to cause you to die. Don't do that. Keep your history on the old system. So when people need it, they go to the old system and they know how to find it. And then over time, and as resources clear up, you can move over the more important history to the new system. But direct cutovers are extremely high risk, because if you have one hiccup, you can't do business. But they are the cheapest to implement, which is why companies do it. Okay. So direct cutover is just that. Cut, die. Parallel is where you have two systems and they're doing the same exact function. Okay. And then you have your big cutoff date. Okay. This is actually a very good way to run a project if you have the resources. Think about your data entry people. Now they have to do data entry on two systems for every order that they do. And if you don't make your parallel project wisely, you will have a revolt and a mass exodus. Okay. And phased is similar to parallel in the sense that you taper one off and the other one tapers up. This one is exceptionally complex. Okay. This is really hard to do because which part of the system do I turn off first to be able to put on the new system to be able to move over from old to new? Again, resource capital intensive. Okay. But low risk. Okay. And then my favorite was the pilot project. You do something and you make it small, you make it cheap, you make it fast, you prove it works. But while you're building it, you know you can scale it, because if you don't make your pilot project with the ability to scale, it's not going to fly. Okay. All right. So pilot projects is a great way to find out if you have a business use case for this idea that you want to implement. Okay. Pilot projects are fun and they're usually very low risk, but it takes somebody or a group of people out of their main day jobs to go tinker with something that might be valuable to the company. And in most of the companies I worked for, if two people could do the same job, one of you was redundant. So they would basically reassign people or fire people. So there was one person taking care of the entire system. Good business practice? I didn't agree with it, because what if that one person got hit by a bus? Nobody knows their root password. They can't get in. So over time, those companies are either out of business or they've modified it and they realize, you know, we can't make people work 60-hour weeks all the time. So let's get two people working on the same position so that you can get days off. Yeah, lawsuits also cause that to happen. Okay. But pilot projects are usually low risk and they could be a lot of fun because you get to play with some different stuff. Okay. All right. So let's go back to my screen share so I can show you this risk picture. And we'll talk about it here. Now, you will see on my website that I have fail fast, learn faster. Well, there's a reason for that. Because let's say that here's our risk, increasing risk is going up and down, and time is going across. Now, there's something that's missed here, is cost. Cost of the length of time. So there's cost here, and then there's value to the company, which is the vertical axis. So time and cost are across the bottom here. Let's say that each one of these phases is a quarter, first quarter, second quarter, third quarter, fourth quarter. What if you have a major failure at your, right around here, okay? Somewhere around in here. There's a major failure. Your project is not going to work. And you go, uh-oh, now what? Well, you'll go back and you'll do forensics on the project, and you realize that you could have mitigated all of that pain and anguish if you'd taken the steps here before you started spending a bunch of money down here. When cost is down, when you barely spend any money, that's when you want to fail. You want to fail early so you don't spend a lot of money, okay? So that's why they say fail fast. There's a reason for that. If you take your time and you implement this project and you realize that once it's implemented, it won't work. You've got this entire spectrum of a project that is not going to meet the business needs, and you have to trash all of the cost and start over at square one, okay? Not a fun place to be when you're a project manager, okay? So this disaster recovery and all this stuff kind of plays into the risk to the company, okay? And some people, this was in one way it was kind of fun, but in another way it was kind of not. Is my bosses would say, we want 24/7 uptime. Yeah, are you sure you want 24/7, 365 uptime? Are you sure? You really sure? So I would spec everything out to be exactly not one lousy second of downtime. And it was tens of millions of dollars because of all the redundancy you had to put in place. And I said, they said, why so much? You said 0 downtime. I said, can we have 20 minutes a month for downtime? You know, oh, okay, yeah, maybe 20 minutes would be okay. And then the cost just drops dramatically, because now you can turn things off, patch them, and bring them back up, okay? But you have that 20-minute window. This is why they call it the mythical 5 nines. You know, 99% uptime, well, 99.99999, 5 nines, is virtually impossible to get to, okay? So if you can say, I want 99.0% uptime. So figure out how many seconds or in a year, and then figure out 99% of those seconds. Those are how many seconds you can have per year as downtime. And then you allocate those downtime seconds on your quarterly updates for security patches. Generally, management will buy into this if you explain to them that 5 nines, 100% uptime was going to cost you more than you're ever going to get out of the system. They don't like that. You think, well, you know, it's going to cost you $12 billion to get this. And do you really need it? You know, like, how many people are actually really working Sunday at 2 o'clock in the morning? And you can say, well, according to the logs, there's not one soul logged into the company except the night shift. Nobody's doing any, yeah, about 1% a year, whatever it is you want to play with. You can play, 0.05%. You play with it. But basically, you figure out the cost of downtime. And there's charts out there, how many seconds of downtime is 99.99, how many seconds of downtime is 99.39, 49, 59. And you can start seeing, you start thinking about it. If you never reboot your machine and you never turned it off, what would you have to do to keep everything on your machine up and running 24/7? You'd have to have a heartbeat. You have to have a machine that supports a heartbeat where it sits there and chats with one another. They sit there and talk. So if one goes down, the other one picks up the load, and it just keeps working away, and there's never any downtime. You may not be using the system, but there's no downtime. And that can get really expensive, okay? So, but the reason I wanted to bring up disaster recovery is to bring it to your attention that if we get into full-scale cyber war, there's going to be issues. People's credit cards won't work. People's debit cards may not work. What do you do? You know, I'm not saying go be an end of the world prepper or anything. You know, but it's prudent to have backups. Okay, like in my car, I come from a long line of outdoorsmen. So in my car, I always carry water, and I always carry stuff to start a fire. That's what I've done. Well, I spend a lot of time camping, and it's just easy enough to keep that stuff in the car rather than take it out all the time. Okay, it's the same thing with your computer. If you get in the habit of doing good backups, then you don't get stuck in this situation going, oh no, now what do I do? Okay, because the day may come where the internet goes down and it doesn't come up for months. What do you do? I don't know. What do we do? Okay. This was an argument we had in the early days of the internet. We needed two internet. We need two of them, one for commerce and one for personal stuff. Well, that idea never took off because it was expensive. And one of the big worries in the early days of the internet was the internet's going to turn into another broadcast medium. Well, if you've watched Hulu, you know exactly what I'm talking about. You watch Hulu, you get a commercial. But now you get a customized commercial exactly related to the click habits that you've done with your browser. Okay. And you'll find more and more websites about cookies and disabling and enabling. More and more of that. Well, it's all about harvesting data to make you spend more money. Follow the money. Is profit an evil word? Okay, that's up for you to decide. Okay, 8 hours, 44 minutes, and 9 seconds would be 1% downtime per year, and that's actually a legitimate number because that way you can bring the machines down for a couple hours when something really does go wrong. Say like you get 3 bad disks and you have to store them all. Okay, you have to bring the machine down. Although most of the machines have, you know, the high-end servers have hot swap. So the disk drive that goes dead, turns red, pull it out, put another one, and all the software and firmware in the background rebuilds the drive and picks up where it left off. Pretty freaking amazing. Okay, that's what the cloud is all about. You know, that kind of redundancy. Okay. All right, that's kind of what I wanted to talk about for this evening. Was give you an idea of this concept of risk and disaster recovery, because I personally believe that the next thing after cyber is things just not working. Okay, somebody gets into your system, takes over your system. Well, they don't want your system anymore. They found what they wanted out of your system. Now they trash your system. Now you have to rebuild that system from what? That is a question you need to ask. What are you going to rebuild with when there's nothing to rebuild on? I don't know if you watched the very original Star Trek, but Kirk and Spock get thrown back in time. And Spock says, I'm trying to create a reasoning computer with bear skins and stone knives. Okay. And that's kind of, you know, what is it? Einstein said, I don't know how World War III will end, but everybody will be using sticks and stones after World War III. Okay. So who knows? All right. How effective are denying cookies and using script blockers for websites? You need to read more. There's something called browser fingerprinting based on things on your browser, in your browser, unique numbers in your browser, unique numbers in your CPU. They can thumbprint or fingerprint your browser and know it's you on site A and you on site B. Okay. So if you're on the internet, it's really hard to be completely anonymous. You know, you can start by using something called tails or cubes, and you boot this operating system and you'll immediately go into Tor. Well, guess what? They have the IP address of your internet service provider that's on your router. They know it's you. So you say, okay, I don't want them to know it's me. I'm going to go to Starbucks. So you go to Starbucks, you set it, and then you use the Starbucks login, and you have to log in, credentials, and you have to do the two-factor to find out if it's really you. Okay, I'm going to create 5 fake Gmail accounts so I can do this sort of thing wherever I want. Well, now you're starting to get somewhere. You need to really work hard at creating a whole false identity, and it's not easy. And there was a fellow that actually challenged the internet. He challenged folks to do this. I can't remember the guy's name, but I think it was in Wired magazine. And what he did is he basically said, I'm going to drop off the grid, and I know all these security techniques, and I'm really going to try to stay off the grid so nobody can find him. Well, it wasn't but 5 days and they found him. And it was pretty remarkable that they found him because he'd done everything. He had a fake passport, fake credit card, fake, everything was dummied up. But they found a couple pieces of information that connected the old him to the new him. And then they just started following the new him and they got him. And it was remarkable, both sides of what he did to try to protect himself and then what they did to find him. So the only real way not to be tracked is to never be in the system. Never get a social security number, never get a driver's license, never get a credit card, never get, you know, a bank account. And you start going on down the list. How do you function in modern society without all those things? You know, pretty tough. Okay. Yeah. So it's an interesting exercise to read through some of the common things that Joe Average can do to protect himself online. One of the things I like to do is call my credit card companies and say, hey, I lost my credit card, even though I'm holding it in my hand. And then they issue a new number. Well, if my credit card is out in the wild, well, it's no longer valid. Okay. So that's a good thing to do. Changing your passwords is a good thing to do. And some of you say, well, if I change my credit card number, I got to go change all those accounts. Well, most of those accounts you can use PayPal. Then you only have to use it once. Okay. So, all right. So 1% of a year is 3 days, 15 hours, and 39 minutes. Okay. All right. So that's more than enough downtime for most companies that run big equipment, because the big equipment has some phenomenal uptime. We measure the uptime in AIX in years, not days, not months, but years. And Windows, the only reason we had to reboot AIX because Oracle runs on everything. Therefore, it doesn't run well on anything, and it has memory leaks. So you actually have to bounce Oracle on AIX to get your memory back. That was the only reason we had to bounce box. It wasn't because of IBM, because of that. But anyway, that's what I had to say. So what I want you to do is take a few highlights and put it in the notes and ask yourself, what if I lost everything today? My house burned up. My phone was in the house. Everything went kaput. How would I rebuild my digital presence? Oh, no problem. I use my Gmail account and I just get a new phone and have everything loaded on my phone. That's fine. But what about your PC? What about all the data on your PC? I can guarantee you it's probably not all in the cloud. Okay. You may have backups, and then you have to install all the software, and then you have to verify that it works, and so on and so forth. Okay. So just keep this in mind if you actually had to do some disaster recovery. Okay. External hard drives, only if you can run from them. You know, they have the data, but do they have the operating system with all the patches? Every system has this. Since I'm on the board, that's RAID 0, okay, or Mirror. This is actually a great way to run your boot device or your C drive. You basically have two drives. So you have drive 1 and drive 2. And anytime you write to C drive, it goes to both drives. Anytime you read from it, it goes both drives. There's a little bit of a penalty on write, but it does make reading a little faster. But if you get a failure, you just yank one drive, okay? And you can rebuild this stuff hot, depending on your platform. I know Linux supports it if you have the right controller. I don't know about Windows. I know the high-end, all the high-end equipment supports this. Is that you clone a drive, you yank it out, throw it on a shelf. And you do it once a quarter. You put it in, you clone the boot drive, and you see the process is done, you yank it out. Because it's all hot swappable, okay? You just put it in, let it build its thing, do it. And then if you got the time, you flip them and you boot. Oh, it's good. Then pull out the other one, whatever you want to do, okay? So it's a way to do that, okay? Yes, if you use RAID 0, it's on two drives, two physical drives. Mirrored is what they call it, or RAID, you know, 1, what do they call it? 10 or 1 plus 0 or something like that, where you got two drives that everything is exactly the same at all times. Synchronization, okay? And oftentimes you can take one drive and actually put it into a storage unit on another piece of equipment somewhere else and sync it that way across the network. They do that with databases a lot. They call it master and slave for database replication. So you have the master database, and then as things happen to the master database, changes get propagated into the slave, and the slave has a full-on copy of the master. And the only thing you're missing is the transaction logs between however often you set up your synchronization, okay? All right. Yeah, it's everything to do with your controller, okay? Because, you know, software controllers are not going to do this. Like we went through the logical volume manager last week, or no, in the Unix class we did. You can kind of do it in software, but it's not the same, okay? When you have a true hardware duplication of effort, mirroring, is that everything is duplicated. Okay. All right. So, any questions? So think about your disaster recovery. What if somebody hit you with ransomware? Would you cough up the money? I don't know. What do you got on your machine? Okay. Yeah. So I was like, that's it. There was one fellow in my classes that he was a programmer and he was having heartburn with the sysadmins because they didn't play well with others, so to speak. And they got hit with ransomware. And they used a budget light item to pay the ransomware. Management never found out that they got hit with ransomware. Needless to say, the student that was in my classes was livid. Yeah. So ransomware is becoming more and more common, and you will notice you're getting more and more email phishing attacks, spear phishing. Click here for part-time work. They want to steal your stuff. Okay. So it's just beginning. A lot of the spear phishing on Outlook is coming from China. Okay. So you need and they're using stateside servers to penetrate. Okay. LinkedIn is also becoming an attack vector. So don't click on links that are embedded in somebody's profile. Okay. So yeah, you have to kind of, be judicious about what you're doing. Run a whois on the domain name, find out if it's valid, see who actually owns it, see if it's actually real. Take a few minutes to figure that out. Okay. So we have some interesting times ahead. Okay. So that's all I had to talk about tonight. So I know I'm a little short on time, but that's okay. I'm sure none of you will complain. I'm lining up a few more guest speakers. I'm trying to find students or people in industry that have been our students, so they will have a nice pay it forward story. So we'll see how that goes. And I always have a library of guest speakers, so to speak, that are out there that I can have you go look at that I think it's some of the topics they approach make your brain melt. Some of them are really good, and some of them, they're very human. They give you it's good. There's just good stuff. Okay. All right. So questions. All right. That's a good question. What would happen if you installed ransomware onto a virtual machine? Would you be able to get it back onto your main machine? That is really an area of a lot of research right now. There are websites out there that I think Shadow is one of them. Let me make sure that's right. Let me go look it up. Yeah, that's it. Shadow Tech. Yeah. Here, I'll do a screen share so you can kind of see this. This is up and coming new stuff. This is bleeding edge. This is super high speed cloud PC gaming. Okay. Windows only, using the devices you own. They are doing some very interesting things with the virtual machine backup. Think of this as a virtual machine in the cloud that's designed for gaming. Can you penetrate that virtual machine and get into the server on which that virtual machine is running. That's an active area of research, and the answer is yes, sometimes. Okay. Depending on the platform that you are virtualizing on, you can burrow through the virtual machine and get to the host OS. But depending on other hypervisors, you cannot. So this is a very, very much an area of research. But generally speaking, if you're using modern tools like KVM, VMware, I can't speak for VirtualBox, I don't know. You know, okay. Simple ransomware doesn't go from the virtual machine into your machine unless you're doing something like shared folders and you've got there's something common between the two. But if you keep them isolated where you can't even do a cut and paste, then probably not. Okay, because you can create a virtual machine that is completely isolated from your host and you can't even get to it. Okay, you can't copy and paste. You have to use a special access through it's called an appliance, a virtual machine appliance. Okay, all right. So the future is right ahead of you. This is really pretty cool. If you want to play some high-end games on these, and you don't need a high-end PC, yeah, this is something. Okay, all right, let me stop the share. And so, well, that's actually how I had my students figure out the virus. What we did is we found the virus, we captured it, and I saved it. And I actually have it on hard drive. And I've got a big label on it. So do not put this in a machine. But we used it as an external hard drive and didn't boot from it. And actually was looking at what this virus did. And it really looked like somebody had cobbled together by way of object code a whole mess of tools. DNS tunneling, using iodine. So they were actually sending data through DNS. They did a little Bitcoin miner in there, and it had all kinds of stuff just smashed into one giant executable, kind of like BusyBox. And it was a mess, wasn't very efficient, but it really looked like a prototype. And it came from China. And this is 3 or 4 years ago now. But since then, I know China has gotten this thing figured out, and it's far more elegant, a lot harder to track. One thing I can tell you, this was another true story. I went to Spain in 2005, 2006, in the days of Windows and ripping off DVDs. And I was staying with a family, and the family wanted me to work on their PC. So I started poking around on it, and it was just virus after virus after virus after virus. And I go, holy crap, it's got like 600 viruses on it. But I was telling them, this machine, what do you use it for? Oh, we just download movies off the internet that are pirated and we watch movies. And they go, oh, okay. And as I was trimming back the viruses, it was getting slower and slower and slower. So some of these viruses actually made the machine run faster. I'm like, now that's some smart code. So I told them, don't ever do any banking on this machine, okay? No banking. You can do videos. And I showed them all the viruses. They had 200 some odd viruses on there. And yeah, so if you want to infect somebody with a virus, make their machine run faster. Then they will never want to get rid of the virus. Yeah, more useless trivia for you. Okay. All right. Okay, folks. So have some fun thinking through disaster recovery. Spend some time looking at it and find out where it interposes in your daily job. No matter what you want to do or what you think you're doing, or what you think you want to do or what you are doing, just kind of think about disaster recovery. What would happen if blah? My boss and the 2 senior sysadmins got hit by a bus. How would we find the root passwords? Are the machines on site? Can we boot them? Now, AIX has a very clever way of, you forget the root password, no big deal. You go into the computer room and you press F5 and wait for the thing to boot and let you change the password for root. But you have to have physical access. No physical access, no change of the root, okay? And if you have physical access, you can do just about anything you need to do to a machine, okay? All right. On that note, I will kind of stop, and then I'll summarize my notes briefly about disaster recovery. And when the video processes, I'll put it up there, and I'll put the picture that I showed with the, the risk curve about it. So the point of that risk curve is basically you want to fail early in the project so you don't lose money. Okay, that's the takeaway. And the types of projects: phase, direct cutover, parallel. Okay, and my biases. Okay. Yeah. All righty, folks. So if there's no other questions, let me know, and I'll turn off my video here. And people are signing off, it looks like. So, all righty, I will stop the recording. Have a good evening.